Okay, this explanation for average rate of change versus instantaneous rate of change may help you in your physics class. So an average rate of change, it is an average over some interval. So what I'm going to do is I'm going to draw a function here. Okay, so let's just go ahead and put in an axis system, and I'll draw the function here in white. Okay, so let's say this is our curve f of x, right? And so here's our x-axis. Here's f of x on this axis. Now let's say we want to know the rate of change over some interval. Now since this is nonlinear, okay, it's a little bit different than what we had been doing. Before we had just been able to calculate the slope to find the rate of change. Here it's not that easy. Now we can still calculate an average rate of change. And what we're going to do is let's take a point on the curve. Okay, just a random point right here. I'm going to call this x naught. Okay, and so of course its height is f at x naught. Now, if you go ahead and you were to change x just by a little bit, okay, we'll go like this. And so we're going to be over here at x naught plus a little bit. Okay, and then I were to go up to the function, and I were to come over like this, then this guy right here, I'm not going to be able to write it over here because the screen gets small. Also, I'll write it right here. This guy is at f, oops, I'll write it as an ordered pair for you. It's going to be at x naught plus a little bit, and then the function evaluated at x naught plus a little bit. Okay, so that's this point right here, and then we had our original point. Now if I want to know what's the rate of change between these 2 points, that's what we call an average rate of change. So the rate of change between here and here, between my 2 points, is given by this line. Whoops. Let's try it again. It's given by the slope of that line. So the slope of this line, okay, between 2 points is called an average rate of change. So the average rate of change of my function is going to be equal to the slope of this line. And the slope of this line is the change in the y value over the change in the x value. And the change in the y value is f at x naught plus delta x minus f at x naught, right? Because it's, let me write this in here. This guy right here is at x naught, f at x naught. So if I take this guy minus this guy, that's the change in the y. That's this right here. Okay, that's delta y. And then if I come across here, this is the change in the x values. Oops, I guess I have to write this in here. Okay, and the change in the x values is x naught plus delta x minus x naught. Is this guy minus this guy. And notice that that reduces to f at x naught plus delta x minus f at x naught all over delta x. It's the change in the y over the change in the x. Okay, so if someone asks you to calculate an average rate of change, what they're looking for is this line right here on that interval. So even though this is not a rate of change at an exact point, it is the average rate of change between these 2 points right here. Now that's different than instantaneous rates of change. Okay, so an instantaneous rate of change, what that is let's say I want the instantaneous rate of change at x naught. That is this guy right here, which is the tangent line. So an instantaneous rate of change is equal to the limit as delta x goes to 0 of your average rate of change. So as we take this point right here and push it closer and closer, so as this guy comes down the line closer and closer and we get that green line, that is our instantaneous rate of change. So it is just the following, which we have defined as f prime at x naught. So the instantaneous rate of change is the derivative evaluated at the point that you're looking for. So if you want the instantaneous rate of change at x naught, then you take the derivative at x naught. If you want the rate of change, okay, the average rate of change, then you do the difference quotient with the 2 points, just like we have been doing. So in physics, when they're talking about average velocities, this would be the idea of the average velocity. Now in physics, they'll talk about the change in position, changing your x or you're changing your y over your change in your time. Okay, so that would be f at excuse me, f at, let's say, your initial time plus your change in time minus your function at your initial time over your change in time. That's the average velocity. Now if you want an instantaneous velocity, you take the limit as change of t goes to 0 of delta x over delta t, which will be the limit as delta t goes to 0, so as your time change goes to 0, of your difference and that is equal to dx dt. Okay, or you can think about it as f prime of t. Okay, just like that. And so this is in general, if you want it at a specific point, then you pick your time value there. So in physics, just remember that when they're talking about average velocities, they're looking at the slope of the line between 2 points. In your physics class, when they're talking about instantaneous velocity, they're talking about the tangent line, the slope of the tangent line at a specific point.